Chapter 13, Solutions. Exercise 13.91. What mass of salt should you add to 1.8 liters of water to make a solution that freezes at negative 11.2 degrees Celsius? Assume complete dissociation of the sodium chloride salt and a density of 1 gram per milliliter for water. Use the freezing point depression constant of 1.86 degrees Celsius per mole. So given this melting point depression and this freezing point depression constant, we can easily calculate the molality, which is simply 11.2 divided by 1.86. This is the molality of the solution with a negative 11.2 degrees Celsius freezing point. This is equal to, again, the molality. That means we have the number of moles of the solute divided by the mass of solvent in kilograms. What's the number of moles? We don't know. The question is about the mass, so the number of moles is X divided by the molar mass of sodium chloride. Sodium is 23, chlorine is 35.45 from the periodic table. Now we have the number of moles of sodium chloride. Now pay attention to this. Complete dissociation of the sodium chloride salt. This tells us each unit of sodium chloride decomposes into two particles, a sodium plus particle and a chlorine minus particle. So we need to multiply this by 2 to get the concentration of all individual particles in this electrolyte solution. And then we have this divided by the mass of water in kilograms. We have the volume 1.8 liters. We have the density 1 gram per milliliter. We can just multiply this too, and we get 1800 grams, or 1.8 kilograms. We should use the mass of solvent in kilograms here. Now all we need to do is to solve this equation. Now both sides multiply by 1.8. We got this. Alright, and then both sides divided by 2. We got this. And then both sides multiply by the sum of the sodium 23, the chlorine 35.45. So I just copy paste here, and that's going to be the value of X. X is the mass of the table salt we used to lower the melting point of 1.8 kilograms of water to negative 11.2 degrees Celsius. The value is 317. They also calculated the molality first. Alright. And then they use the molality to and the mass of water to get the number of moles of sodium chloride, and then finally the number of moles of sodium chloride multiplied by its molar mass. You will get this the mass here.